In April 2026, VERCEL suffered a security breach that bypassed their primary defenses entirely. The core hosting and operational infrastructure remained fully intact, yet the attackers successfully compromised internal systems. VERCEL's operational services ran flawlessly throughout the event. However, the company had to directly contact a limited subset of customers to notify them that their deployment credentials had been exposed. The technical paradox of this incident is how an adversary accesses internal environments without triggering alarms at the edge. They didn't break through VERCEL's enterprise firewalls or brute force administrative panels. This diagram maps a standard modern CI/CD pipeline. The central VERCEL core is surrounded by peripheral nodes like GitHub, Google Workspace, and various AI extensions. All of these are connected by glowing trust lines. The true perimeter of a platform extends to the absolute edge of these third-party connections.
The breach originated here, Context.ai. It is a seemingly minor third-party AI tool that a single VERCEL employee had integrated into their workflow. By compromising this specific integration, the attackers established their initial foothold. Adversaries rarely attack hardened primary platforms directly anymore. The path of least resistance is to weaponize trusted third-party OAuth integrations to pivot inside. In a decentralized SaaS architecture, an organization's internal security is strictly bound by the weakest permission granted to its most peripheral integration. To derive the exact mechanics of this attack, we start with the external compromise. The attackers breached Context.ai entirely outside of VERCEL's jurisdiction. Google Workspace OAuth applications function as delegation frameworks. They grant a third-party tool explicit permission to act on behalf of a specific user. The intruder seized control of Context.ai's OAuth application itself, granting them the ability to abuse those pre-existing delegated permissions across multiple organizations. This flowchart illustrates the compromised node. VERCEL published this indicator of compromise, an OAuth client ID starting with 110671. Attackers use this to issue a spoofed request to Google Workspace, bypassing standard login. Workspace validated the token, silently handing over the employee's VERCEL-linked account. Armed with this hijacked identity, the intruders did not have to hack into VERCEL. They walked straight through the front door, perfectly cloaked as a legitimate internal engineer. Once inside the VERCEL environment, the attackers escalated privileges and navigated the internal architecture with remarkable operational velocity. OAuth delegation frameworks are necessary for modern automation. However, they create a persistent vulnerability. Trusted identities can be perfectly impersonated without the attackers ever needing to steal a password. After infiltrating the network, the attackers executed their lateral movement by targeting the environment configurations of specific VERCEL customers. This diagram shows VERCEL's architectural divide. On the left, sensitive environment variables are encrypted and strictly read-prevented, mathematically blocking intruders. On the right, standard environment variables are stored in plaintext. Possessing an authenticated identity, the attackers successfully queried and extracted these readable standard variables. The exposure occurred due to a common operational error. Users frequently store critical API keys, database credentials, and signing tokens in these readable standard variables, rather than utilizing the protected sensitive tier. The attackers rapidly enumerated these readable variables. They harvested the exposed plaintext secrets and used them as vectors to further penetrate the specific internal projects of targeted customers. The internal blast radius of a compromised identity is constrained entirely by default architectural states. Read prevention halts lateral movement cold, while plaintext inevitably enables it. The breach triggered immediate community fallout, heavily fueled by severe, unverified claims circulating on dark web hacking forums regarding the actual scale of the attack. A threat actor using the moniker Shiny Hunters posted a listing demanding $2 million. The actor claimed to possess 580 employee records, internal source code, database info, and critical NPM and GitHub tokens. The specific mention of NPM and GitHub tokens caused immediate alarm within the cryptocurrency and DeFi sectors, which rely heavily on VERCEL for production deployments. This fear stems directly from past supply chain incidents, like the Ledger ConnectKit breach. In those cases, compromised downstream tokens allowed attackers to inject malicious code straight into decentralized finance front-ends.
However, we must explicitly contrast these high-profile extortion claims with VERCEL's thoroughly investigated official incident parameters. VERCEL, alongside external incident response experts, found zero evidence to corroborate the exfiltration of source code, internal databases, or explicitly protected sensitive variables. The confirmed impact was limited strictly to the readable standard variables. DevSecOps teams face a dual challenge during a major incident. They must secure mathematically provable attack paths while actively filtering out the operational noise and extortion tactics generated by opportunistic threat actors. Securing a VERCEL environment post-incident requires users to execute specific, mandatory actions. First, administrators must audit all account activity logs through the VERCEL dashboard or CLI, scanning for any anomalous deployment behavior during the April window. Second, a strict rotation mandate now applies. Any secret, token, or API key that previously resided in a non-sensitive environment variable must be considered compromised and rotated immediately. Next, teams must upgrade their internal deployment protocols. This means setting deployment protection to the standard level and rotating any associated bypass tokens to invalidate historical access. This architectural fix requires critical data strings like API keys and DB tokens be migrated from standard readable folders and locked inside the sensitive tier. This ensures that even if an attacker achieves authenticated access, the keys cannot be extracted. Beyond VERCEL, the broader industry lesson is clear. Third-party AI tools and their associated OAuth integrations can no longer be viewed as harmless extensions. They are Tier 1 threat vectors. Modern CI/CD pipelines require a strict zero-trust philosophy for secrets management. Trust is never implied, regardless of the user's authentication status. Engineering teams must operate under the assumption that their external platform perimeter will eventually be bypassed, and it will be done using a perfectly valid, trusted identity. True infrastructure security doesn't rely on keeping attackers out. It relies on aggressive internal read restrictions, ensuring a hijacked identity yields absolutely no actionable secrets.